Welcome to DDevOps Academy, your gateway to mastering modern DevOps tools. In this course, we dive into Docker, the powerful platform that simplifies application deployment using containers. Whether you're a beginner or brushing up your skills, this journey will equip you with practical knowledge to build, ship, and run applications efficiently. Let's get started with Docker. In this module, we'll explore Docker, a fast, lightweight platform for building and running applications in isolated environments. Released in 2013 by Solomon Hykes, Docker revolutionized deployment with containerization, making it the go-to choice for microservices. This course covers everything from Docker architecture to hands-on labs. Let's dive in and simplify DevOps with Docker. Let's break down virtualization versus containerization. Virtualization uses hypervisors to run multiple operating systems on one machine, each in its own virtual machine. Containerization, on the other hand, isolates applications at the process level using a shared OS kernel. This makes containers lightweight, fast, and perfect for microservices. In short, virtualization is heavier, containerization is leaner. Let's clarify a core Docker concept: image versus container. A Docker image is a static blueprint. It defines the code, dependencies, and environment needed to run an app. A container is the live, running instance of that image. It's isolated, portable, and ready to execute. Think of the image as the recipe, and the container as the dish served from it. Explore Docker's architecture. Docker uses a client-server model. The Docker CLI sends commands like build, pull, and run to the Docker daemon. The daemon handles containers using a runtime on the host OS. Images, like Ubuntu, Redis, or NGINX, are pulled from registries and turned into running containers. This setup ensures efficiency, isolation, and portability across environments. Let's go over some essential Docker commands. First, Docker version shows your installed Docker client and server. Use Docker pull to download images like NGINX. Docker images lists what's stored locally. To run a container, use docker run-d-p 8080:80 nginx. Check running containers with Docker piece and stop them gracefully using docker stop. To install Docker, just run sudo apt install docker.io. These commands form the foundation of your Docker workflow. Let's continue with more essential Docker commands. Use docker rm to remove stopped containers, and docker rmi to delete images. To build a custom image from a Dockerfile, run docker build-tmyapp:1.0. Need to run a command inside a container? Use docker exec-it container_id bash. View logs with Docker logs and manage multi-container apps using docker compose up-d and docker compose down. These commands give you full control over your containerized environment. A Dockerfile is your blueprint for building Docker images. It defines the base image, working directory, dependencies, and the command to run your app. For example, using from Python 3.10-slim, we set the base. Then we copy files, install packages, and define the startup command. This ensures consistent, repeatable environments for development and production. Let's walk through the Docker workflow. It starts with a Dockerfile, a blueprint for building an image. That image packages your app and its dependencies. When you run it, it becomes a container, a live, isolated environment. Now about Docker volumes. They're used to persist data. Volumes link your host system to containers, allowing data to survive even when containers stop. This setup is key for managing stateful applications. Docker networks. User-defined bridge networks are great when containers need to talk on the same host. Host networks share the host's network stack for performance. Overlay networks connect containers across multiple hosts, perfect for swarm setups. McVLAN networks give containers their own MAC addresses, ideal for VM migrations. And third-party plugins let you integrate with advanced network stacks. Choosing the right network type is key to building scalable, secure container systems. Welcome to your first Docker hands-on lab. In this exercise, we'll pull the NGINX image, run a container, and verify it's working. Start with docker pull NGINX:"latest." Then launch it using Docker run-d-p 8080:80-name web server nginx. Check it's running with Docker PS. And finally, open your browser to http://localhost:8080. You should see the default nginx welcome page. Your first container is live. In this lab, you'll build your own Docker image from a Dockerfile. Start by creating app.py with a simple print statement. Then write a Dockerfile using from Python 3.10-slim. Set the working directory, copy your files, and define the command. Build the image with docker build-t mypythonapp. And run it using docker run-name python-demo mypythonapp. If everything's set up right, your terminal will print hello from inside a Docker container. In this lab, we'll learn how to persist data using Docker volumes. First, create a volume with docker volume create my data. Then run a container using that volume. Docker run-d-v my data /data --name vol-demo. Busybox sleep 3600. Write data inside the container, stop and remove it, and finally start a new container with the same volume. If done right, you'll see hello volume printed, proof that your data survived across containers. Let's containerize a React application. First, clone the GitHub repo and navigate into the project folder. Then, build the image using docker build-t dockerize-react. Finally, run the container with this link. Your React app is now live inside a Docker container, ready to scale and deploy.
Thanks for joining us at DDevOps Academy. Docker isn't just a tool, it's a core DevOps skill. By mastering it, you'll build, ship, and deploy applications faster and more reliably. Our training focuses on practical, industry-ready learning to keep you ahead in your DevOps journey. So keep practicing, keep experimenting, and take the next step toward becoming a confident DevOps engineer.